All right, so in our second section of the year, we are looking at segments and congruence. One word that you're going to see quite often is postulate. Axiom isn't used so much, but really just think of it as a rule in geometry. Okay, it's nothing more than that. So don't get hung up on a fancy word that you've never seen before. It really just means something that we accept as true in this class, and a lot of geometry textbooks have that in it. All right, so the distance between any 2 points is the absolute value of the difference. What does absolute value mean or do to a number?
It's the distance away from 0.
Okay, what's another way to think of it? That is correct so far. If you take the absolute value of a number, what does it do? Makes it positive. So if it is already positive, it stays positive. If it's negative, it just takes the negative off. So why would the distance be considered something that is absolute value? Yeah.
You can't have a negative distance.
Correct. You can't have a negative distance. Okay, so that's the only reason that that's in that definition. So if we're looking here and we want to find the distance from A to D, let's put dots on those. So here's A, here's D. We want to find the distance between them. Okay, there's two ways to do it. We can count, or we could look at the difference and take the absolute value. Okay, what does the difference mean? Add, subtract, multiply, or divide? Yep, so let's take -8 minus 3, and if we take the absolute value of that, what do we get? Well, it's -8 minus 3. -11. Okay, which means our answer is 11. Okay, you can also count as well. Questions there? All right, segment addition postulate. We're going to be using this a couple times throughout the year. Here's your first introduction to using algebra that you learned last year on a picture. Okay, a lot of what we do this year is going to be Algebra 1 stuff. So it's attached to a picture, but what this postulate up here says is that if you take AB, so this chunk right here, and you add BC, we should get the entire length, which would make sense. If you take this part plus this part, we get the whole thing. So that's how we're going to set up this algebra problem over here. We have 3 plus 12. It has to equal the whole thing, which they have labeled as x. Okay, well, this is very basic math here, but they're going to get a little bit more difficult, but not much. So looking at the next one, if we set it up the same way, what plus what equals what? What two pieces will we add together? Yep. 4x minus 2, and we're going to add that to the other part of the segment, which is 3x, and it should equal what? 26. Okay, now this is more typical of what you would have seen last year when you're solving for x. All we have to do is get x by itself. So let's review doing that. What do we want to do first? I heard somebody say it. Combine like terms. So on the left, we really have 7x minus 2 equals 26. And yes, we show work in this class just like last year. So we're going to add 2. 7x equals 28. Last step, divide. X equals 4. So a lot of your problems are going to look like that. So this is the algebra that you learned last year. And here's the piece of it that's now going to be the geometry, where it starts as a picture, but you turn it into algebra. We're going to do a lot of that. Questions? Okay, last page then. This one we don't have a picture, but they did give us a description. So RY is a segment with S in between. Let's make this a picture, because it tends to be a little bit easier. So it says RY is a segment and S is in between. So S is in between the 2 points. And our segment is RY. So now we have a picture, and we can label this picture with the information they gave us over here. Okay, so RS is 4y minus 1. And SY is 5y plus 5. And the whole thing is 85. So now it's just like the previous problem that we were doing. So what plus what is going to equal what?
4 minus y, or 4y minus 1 plus 5y plus 5.
Has to equal
85.
85. So again, we're going to combine like terms over here. So we really have 9y plus 4 equals 85. We subtract our 4. All this algebra hopefully is getting dusted off in your brain from long summer. And then we'll divide by 9. And we get 9 for an answer. Last thing, you're going to see this symbol a lot, so I want you to circle it. Okay, it looks like an equal sign. There's just a little squiggle, a tilde above it. Okay, this is the word congruent. So we use this when talking about objects. It means that two objects are the exact same shape and size. So if we had two triangles, let's label them A, B, C, and X, Y, Z. We could say that triangle ABC is congruent to triangle XYZ, okay, because they're objects, they're not numbers. So it's used in the same way that equal is used, but we're going to use it a lot in here because in geometry we're looking at objects, not just numbers. Okay, that's congruent. Any questions on today's stuff?